Hey folks, how's it going? This is Mr. Murray coming to you with a do now for March 27th, 2020. This is an optimal slash recommended for enrichment purposes. We do have a Google Hangout scheduled for today where we are going to continue to work at these roots. So I hope that if you're here, excellent. I hope that you take the second to do this because even though it is optional, I think that every bit of practice that you get will make you that much stronger of a mathematician going forward. All right, I'm a believer that practice makes perfect. So here's what we're going to do. Feel free to take a look at the recap of the week on the right, but for time's sake, I'm not going to go through that in detail. What I want you to do is I want you to simplify these roots completely. So in other words, you need to simplify these roots so that the number inside of the root cannot be further broken down. Okay, so for example, even though there's a 9 outside of this one, right, the number inside can still be broken down. Okay, so what I want you to do, I want you to pause the video. I want you to try to simplify these 3 roots completely. And then when you're ready, unpause, and I'll show you how to do them. All right, so here we go. And if you saw the do now for the previous day, let me just extend this page so I just get a little bit more slack here. So if you saw my do now from the other day, this list of perfect squares is just right out of that video. So the key to simplifying any of these roots, or sometimes people call them radicals, is that you need to find one of these special numbers, a perfect square, that's a factor or that goes into these numbers here. So what I like to do, and I got this great idea from a student this year, is you make this little tree, okay? And then we're going to try to see which of these numbers goes into 96. So, and the idea is we want to get the biggest number possible. If you don't get the biggest number possible, that's okay. But what's going to happen is it's going to take you an additional step to get to the final answer. So I'm going to start at the top, right? We know that whatever number it is has got to be less than 96 because no number greater than 96 is going to go into it evenly. So for example, 100 is out. We can see 81 is not going to go into 96. Neither will 64. 49 might, let's see. Nope, because 49 times 2 is 98. 36. That's not going to work. 25, that's not going to work. 16 will work. So, because you got 16, 32, 48, 64, 80, 96. So 16 times 6, okay? Alternately, you could have broken it down. Since 16 goes into it, 4 also goes into it. So I'll show you what would have happened if you got 412 in just a minute. If you get 16 and 6, so what we know about the law of roots is that because 16 times 6 equals 96, the square root of 16 times the square root of 6 equals the square root of 96. And if you don't believe me, I challenge you to punch that into your calculator. First, punch in square root 96, and then punch in square root of 16 times square root of 6, and you'll see that what you get is to the decimal exactly the same. Okay, but the idea is the square root of 16 is 4, okay, and 6, I can't do anything with that. It's not a rational number, so I leave it as the square root of 6. Then I come back through. Can I simplify any more? No, I'm done. You always want to see if you can continue to simplify. All right, and by taking that rigorous approach, you're going to find that you're going to be really successful next year because we're going to look again at a similar thing where you constantly need to go back and make sure you're continuing to simplify. So if I got 4 and 12, which you might have gotten, right? So then I'll do the roots and I'll get 2 root 12, okay? And you notice though that I'm not done, okay? Because the root 12 can further be broken down. Because 12 is 4 times 3, right? So that is what will happen if you don't choose the biggest root. It's going to take you an additional step. So then the square root of 12 is the square root of 4 times the square root of 3. In other words, let's see, I just want to make sure I had that. You know what? Silly Mr. Moray. It's not 12 that I want here. That's why it doesn't work. Okay, so it's the square root of 4. 4 goes into there to 9 twice. 24. All right, so it's 2 root 24. Now, similarly, though, in any case, it is still going to be 2, except now, rather, it's going to be 4 and 6. That makes more sense. So then you'll get 2 root 6, because you get the square root of 4 times the square root of 6, which gives you 2, and you simplify, you get 2 times 2. That's a 4, and then root 6. So you see you get the exact same answer. But again, by choosing the biggest possible perfect square, I get, like in the green version, I get there in only one step. Okay? Now, 175, hopefully, if you ever see a number, if you want to know if it's divisible by 25, look at the last 2 digits. If the last 2 digits are a multiple of 25, the number will be divisible by 25. If you don't believe me, think about it, right? Because, right, I can get 25 times 3 to be 75. And then any other numbers, like literally if you went 1, 2, 3, 4, 5, 6, or I guess 7, 6, 75. If I wanted to know this, right, well, basically by doing 25 over and over again, I can get the rest of these digits figured out, right? I can just keep adding, and eventually this will become a 1. Then I'll roll it around. It'll become a 2, then a 3, then a 4, then a 5, then a 6, 7, 8, 9, 10. It will spill over into this place, and so on and so on. So that's a fun fact. If the last 2 digits are a multiple of 25, so if they're 0, 0, 2, 5, 5, 0, or 7, 5, that number will be divisible by 25. So that's a little division trick. And if you know the division tricks, it'll save you time. If not, it's not the end of the world. Okay, so this is 25, and it's 25 times 7, because it's 25, 50, 75, 100. That's 4. 125 is 5. 150 is 6. And 175 is 7. So if 25 times 7 is 175, then the square root of 25 times the square root of 7 equals the square root of 175. And again, if you don't believe me, go ahead and try that on your calculator. So now the square root of 25 is 5. And now I go back. Can I get anything to go into 7? No, because 4 doesn't go in, and all of the rest of them are more. So I'm done. In this case, we got lucky because I don't think any other number goes into 175. For certain, I don't believe 16 or 36 do, because if 36 would go in there, then 2 should go in there, and 2 doesn't go in there. Okay, so neither is 64, right? Same thing. Challenging one is 9 times the square root of 245. So what I'm going to start by doing is I'm just going to cut off the 9, and I'm just going to look into the square root of 45. Now, if I look, I'm going to have to do a little bit more what I'd call brute forcing, like checking over and over again. Okay, what I know is that if I continue this list, I would get 11 squared is 121, 12 squared is 144, 13 squared is 169, and by the time I get to 15, I'm at 225. None of these numbers are going to go in. Okay? So I'm going to look at the bottom list. And by the way, if you want to know, I would say let's start with the bottom. So first of all, the last 2 digits are not a multiple of 4, so it's not going to be 4. The digits do not add up to 9, they add up to 11. So because the digits don't add up to a multiple of 9, it's not divisible by 9. 16, there's no good way to check 16 that I know of. So what I'm going to do is I'll check 24. 16 goes into 24 once with a remainder of 8. And then 16 does not go into 85. So 16 is not going to work. 25 is tempting, but 25 you'd only get to 250. And again, if you look at the rule, 45 is not a multiple of 25. So that, using our test from the previous one, we know 25 is not going to work. Okay, 36. So if 36 went into a number, then 4 would have had to also go into the number. Because think about it. 36 is a multiple of 4. right? So any multiple of 36 is also a multiple of 4, right? But we know that 4 doesn't go in, so most likely 36 is not going to go in. As it turns out, 45 will go in to there, okay? And as it turns out, it's going to be 9 times the square root of 49 times the square root of 5. One good way to multiply by 5 is you take the number, you add a 0 because that's like multiplying by 10, and then you divide by 2. So if you multiply by 10 and divide by 2, it's the same thing as multiplying by 5. And this is equal to 245. All right? So now this becomes a 9, the 49 becomes a 7, and the 5 remains a root 5. And I then take the 9 and the 7, that becomes a 63. So it's a 63 root 5. Okay? So those are our 3 that we've got there. Again, our answers are 4 root 6, 5 root 7, 63 root 5. All right? So I hope you found this to be informational. I hope you found it to be helpful. And I truly hope that you were able to get the right answers. Keep the questions coming, folks. We've been working real hard. We do need to know this to move on to start talking about the next method of solving. But keep up the good work. Keep your head up during this difficult kind of closure time. And remember, you can do it. All right, thanks much. I'll see you soon, and have a wonderful day.